I'm going to start recording. And so today we're going to do another exercise from the textbook. This one is going to be one of the more fun ones because it will deal with turtles, which we'll be utilizing in weeks 3 and 4 and 5 to help explain how all this works. But before we do that, I want to just do a couple things. I just need to make a few mentions of stuff. First off, if you sent me an email over this past week and I didn't get back to it, I'm sorry. My kid had been sick and basically I've gotten no sleep over the past 3 days. So anyway, I'm doing great. But if you hear me wander, that's if you hear my mind wandering or I just stop for a second because I'm trying to think of the words, that is why. It is because I'm tired. That being said, everything is good at home. If you saw on Discord, I announced that my kid was sick, and so for 2168 they had their lecture yesterday. You should have all had your labs Monday and Friday. Great. And so you all should have had an introduction to like getting Python installed on your system. If you're still struggling with installing Python on your system, please email me as soon as possible so that we can fix that or sign up for office hours. With regards to office hours, some of the office hours for the TAs have been updated. Just check the sign up page. I'm going to make sure that they didn't accidentally block off their office hours, which can totally happen. Also, I modified my office hours to be on Thursdays and Fridays. So Thursday mornings, Friday afternoons. If, however, you cannot make either of those times or you need to meet with me before then, you can always send me an email, and we can find times to meet over Zoom, right? This is my typical way of meeting with students in the evening. So, just check the office hours. That's why I don't necessarily post what my office hours are, because depending on how the semester progresses, I might find the need to change them. Okay. So the itinerary for today, for want of a better word, is that I'm going to review a bit of Python. Okay. Just a bit of Python and Python programming and idle. A lot of the stuff that we should have learned that you should have seen in chapter 2 if you've been keeping up with the readings. So over here again, right? So if you go up to Runestone and you click on the person icon on our page and hit assignments, it'll bring up what you need to read. If you find that reading is really hard for you, then I should also note that in my modules, my videos over here, they go over the same material, right? This is just the same material in the textbook, and it is in fact produced it is actually like listed section by section. So you can watch the material or read the book, or do both. The book is the way to just check it off, though, right? Make sense? So depending on which way you prefer, and again, these videos, I try to keep them short. This first one is 2 minutes long, 13, 7, 2, 5, 7. I try to keep them fairly short so that you can basically just, so that you can do them in very digestible chunks, and that they are going to be much less than 2 hours a day. Sorry, 2 hours a week. So, and again, if you feel like that I'm giving you too much, or it's something that I need to go over in class instead, again, let me know. I take suggestions about your teaching very seriously when it comes to the ones being taught. Okay, so we're going to go over a bit of that. Then what we're going to do is that I'm going to give out a knowledge pre-mastery quiz. So basically these are a series of questions that allow me to track understanding of concepts before you come in and concepts after you come in. You do not have to panic about this because you're going to get the same grade regardless of what your answers are, which is that you're going to get 5 extra credit points for taking this quiz. Okay? So it's not anything to worry about. It's literally just for me to track basically what did you know before you came to this class? Probably not much about coding. What did you What do you know after you got out of this class, after you took the final exam? Hopefully a lot more, you know, so this is, and this isn't like student per student, I don't think. It's more like, you know, what percentage of the class, I believe. So, and then we will go over this, this stuff. Sorry, this exercise that we have set up for today. Okay. So hopefully you have downloaded Python and installed it on your computer, right? If you have not, right, watch the video that I have on how to do that. You can find that video under modules, installing Python. Python comes with idle, just packaged with it. This is idle is what we call an IDE or an editor. IDE, it's a very basic IDE, very much closer to an editor, but basically that means it's an integrated development environment, meaning you can do all your writing of your programs in here. Now, the font size from right now is very small. So if I want to adjust that, I can just go to Options, Configure Idle, or if you're on a Mac, you just hit on the global menu, the thing up, you know, the title icon for it, like where it says idle, and you can just adjust that by hitting Configure Idle. And then you can change your font. I'll be using a monospace font. Let's see, can I choose Cascadia code? Yes, I can. I can choose Cascadia code. Wonderful. And then I will up my font to something that can be seen from. How's that look in the back? You want me to go another step? Yeah? You want me to go another step or no? It's fine? Up? Okay, okay. All right, let me know if you need me to make it bigger. Just like shout at me or something. All right, so idle has two basically windows that you'll be working with. The first is the script window, which is how I got that was I hit File and then hit New, or you can just press Control N and it will generate one. Or if you're on a Mac, Command N. This is basically a new document. This is a script. On the right, we have the shell. This is our way of talking with the Python interpreter. The way the Python programming language works is that it is running, in order for us to run a program, we are running a different program called the interpreter. And what that does is that it translates Python code into the code for our machine. So if I were to tell it, so if I were to ask it to give me 5 plus 3, it would translate the command 5 plus 3 into the machine code and then give me back the answer from the computer. 5 plus 3 is 8. It just kind of automatically prints the stuff when you're in here. This is useful when the shell without the script is actually pretty useful if you want to do some quick and dirty one-liners. Just basically doing some very basic kind of math operations or some algebraic operations. They're pretty good. Like, because as I've mentioned in the videos, you can do all the arithmetic operations you're used to. 5 plus 3, 5 minus 3, 5 times 3, star, of course, of that, and then 5 divided by 3. And of course, who could forget 5 divided by 3? And of course, 5 modulo 3. Who could forget that one either? These are all different. So division gets a bit tricky in programming languages because we have very, very different kind of commands of what we want to do. The first one in Python is pretty unique in that it gives the first one we do, which is the one you're going to naturally gravitate towards, gives you the answer you'd expect. This is not true in other programming languages, unfortunately, but it gives you the answer you expect. If you divide two integers, two whole numbers with each other, using a single division sign, it gives you the floating point number you'd expect. In other words, a number with a decimal place in it. If, however, but a lot of times with but over here, this is a bit of a holdover, but also a useful tool from older programming languages, where if you take two integers and you divide them, you sometimes you want to get the same type out. So an integer divided by an integer should give me a whole number. If I give you two integers, I should get an integer back, right? If I give you some stuff without decimal points, no decimal point in the output. So that's what we're doing here. You can think about this as fourth grade division, right? where you learn how to divide in 4th grade and they don't bother mentioning how to do decimal points yet, right? They just say, okay, if the quotient is, they say 5 divided by 3, the quotient is 1 and the remainder is 2, right? And that's what the next one is, modulo. 5 mod 3, it's a nice, pretty, there's this wonderful, algebraic definition for modulo. Don't worry about it. Just think about modulo. It's basically doing division, but instead of getting quotients, you get the remainder, right? So 5 mod 3 gives you the remainder of 2. We will see where this comes in use much later in the semester, okay? Where it's useful for seeing if numbers are odd or even, or switching things on or off, or seeing if things are evenly divisible by another number like 5 or 10. So those are our kind of, so for these 3 operations, you don't really have to worry about anything. For division, you might have to consult your notes, but honestly, it's not going to be anything like, I'm going to try to avoid like any kind of trick questions like that about these. There is one more useful operation built into Python that I should mention, which is exponentiation, right? How to do exponents, right? And by which I mean, of course, if I wanted to do like 5 squared, right? Sorry, 5 squared, or as we more commonly write, like 5 squared. Now, Python's a bit weird, or programming's a bit weird again here, because if you try 5 caret 2, which is normally how you would write exponentiation, right? It gives you 7, which 5 squared is not 7, right? So that obviously isn't it. This is actually a different logical operation. I believe that is the logical OR operation. So we are kind of, it made it kind of weird there. Don't worry about that. Instead, what you should know exponentiation is actually pretty clever. Doing 2 stars is how you do exponentiation in Python, right? So, and that makes sense because doing exponentiation is often just a shorthand for doing repeated multiplication, right? Much like doing multiplication is shorthand for doing repeated additions. Nothing too scary here, right? These are all operations you will have learned about in any of your algebra or pre-calc classes. These are nothing too scary, and they are basically a lot of the bread and butter of what we're going to be using. Okay. There is one thing though that we do need to be aware of in Python, which is the way the equal sign works. Okay. Which is that we use the so if I were to say 5 equals 3, 5 equals 5 over here, right? It tells me this. You cannot assign literal here. Maybe you meant double equal instead of equal. So we'll learn more about double equals later, but we have something, but when you see a single equal sign in Python, it is what we call the assignment operator. It sets things equal to a value. For instance, this would set the value of x equal to 5. And this would set the value of potatoes equal to boil them. Okay? So these are what we call variables, right? And you recognize them from, basically any time you've been subjected to algebra, right? You have these variables. Now, one reason I did this whole entire thing with potatoes is to point out one of the really nice features about Python, which is that you aren't limited like you are when you're working on paper. I mean, technically you're not limited to working on paper, but it's a pain. You aren't limited to using a single letter for your variables. It's always f of x is equal to, and you forget what every single variable is, and then they run out of it, and then they run out the English alphabet, so they bring in the Greek alphabet, and you see this little squiggly line, and you have no idea which that one is, and you're like, is that theta or no, that's capital theta apparently. So none of that. We can use multiple letters for our variables. And in fact, it's very good practice to name your things, your variables, what they matter. So if you're counting something, so if you're counting people, you might call your variable num people, num underscore people, where the underscore, and why the underscore? Because the variable name has to be one quote unquote word, if that makes sense. So the way you make it 2 words is by putting another character in there. Being the underscore is one way to kind of show that you actually have 2 words in there. So num people, it's useful for humans to read. So num people is equal to 7 or something. Okay. And then if you want to keep track and increment that or decrement that, it works. But anyway, we can use this as you would in any algebraic operation, right? It works exactly as you would expect it. So like 5 times x, oh, sorry, let me do 2 times x, right? 2 times x gives us 10. X plus 3, 5 plus 3 gives us 8, right? Nothing too scary over there. Much like a calculator, though, or a lot of calculators, you can't do 7x like this because it gets kind of confused as what you're doing. So, right, if you want to do multiplication, and that matters for our second assignment. Some people try to do that, where they try to, write it algebraically, but you got to put your multiplication sign in to be explicit about that. It's a bit of a nuisance. But it works exactly the way you think it is. Here's the thing about the assignment operator. You can reassign the variable. X is now 6. So if I do 2 times x, it becomes 12. It changes. Doesn't invalidate the previous statement, by the way. X is now 7. X is now 6, and so this operation changes that value. The way to think about this, this is kind of the first hurdle, and it takes some practice. But the way to think about this equal sign is that it wasn't always an equal sign in all the old programming languages. It was sometimes sometimes something weird, like this operator, which I'll get into. It's easier to think of the equal sign as kind of like this, an arrow, saying, I want to store 5 inside of X. Take 5 and store it inside of X. Boil them and store them in potatoes. Okay. But of course, the issue, we couldn't really use an arrow in ASCII because, or standard keyboard layout, because this would kind of be interpreted as the statement X is less than -5, right? And certainly making that longer doesn't help, and certainly not making it an equal sign, that doesn't help. None of that helps. So that just didn't work for early computers. So some languages like ALGOL, I believe, use what we call the walrus operator nowadays, because if you look on your side, it kind of looks like a walrus with his eyes and 2 big tusks. To kind of do the equal sign, and eventually we just got rid of the eyes and we're left with the with using the equal sign, because less keystrokes. So again, think of it as taking the thing on the right and storing it on the variable on the left, and it is always storing it. It is always the variable is on the left. For instance, if I were to do 5 is equal to y, we're trying to take a value on the right and store it in the value on the left. Okay. Okay. So it's got to be variable on there. So this is where. So now I've got to make sure you understand how it works, which is that it works the way that requires the least brain power for you to use. I like that because, again, I'm tired. I don't want to use my brain power right now. So x is equal to. So let's go ahead and say x is equal to 5 again. Y is equal to X. They're both 5, right? So if I ask for X, it's going to give me 5. If I ask for Y, it's going to give me 5 back, right? So what happened? I did 5 is equal to X. 5 is, so when we did y is equal to x, we said take the value inside of x and store it in y. Take this value, look inside x, see what the number is, put it inside of y. Okay, it doesn't have to be a number, but in this case it is. So when I say x is this and y is this, it changes. Now, when I change x is equal to 100, right? X is equal to 100. This says take 100 and store it in x. Now, if you're coming from a very rigid rigid mathematical thinking, you are going to be forgiven for thinking that if I ask what the value of y is, you would say 100. But no, it's 5, because this is a very weak binding. It is says take this value, store it on the take the value on the right, store it on the left. So this unpacked not x, but it took 5 and stored it on the left. It didn't take x and store it in y. It took 5 and stored it in y. Make sense? So when we changed one, it didn't change the other. And this is why I say it requires less brain power, because if you imagine doing that for a lot of variables, suddenly you'd have to remember, wait, which ones are associated with which ones? When I change this one, does that change this one as well? That gets very complicated very fast. So again, remember that, and all the confusion is because this is deceiving. This equal sign is the assignment statement. It doesn't work the same way as an equal operation in math. That's the biggest source of confusion. So now your homework for that you'll be presented on Friday, which is consists of Friday or Monday for your lab, consists of, I think, 3 or 4 separate problems. Okay. The first is an old equation for calculating BMR based off of 2 equations based off if you are male or female. You don't have to ask the user's gender. What this does, I just simply want you to calculate it both equations. I'm not asking because it would require if statements. And what this does is that I'm not actually asking you for the BMR. So the BMR is your basal metabolic rate. That is how many calories you burn just by existing, because that brain of yours requires a lot of calories. Also, all the other systems require a lot of calories. So this is just simply the number of calories you would consume if you were just staying in bed all day. Okay? And these are estimates. So and what I'm asking is not the basal metabolic rate, but how many chocolate bars is that equivalent to? And the average chocolate bar is equivalent to 214, is equal to 214. So this is a conversion problem. In fact, a lot of these are conversion problems. I'm asking you to convert the basal metabolic rate to chocolate bars because that's funny. Next is I have this program that I need you to debug. It's a bit weird, but it's fine. And I give you a hint if you can't find the error. This one's a classic one. Write a program that converts Celsius to Fahrenheit. I've given you the equation in case you just need it for reference, right? Celsius to Fahrenheit, not Fahrenheit to Celsius. If you do that, we'll just simply ask you to rewrite it. It probably won't take you like a minute. So you could probably rewrite it during the demo if you make that mistake. And then finally, which is the trickiest one, fourth is definitely the trickiest one because it involves the modulo operator, that percentage sign that I just introduced, converting seconds into hours. So given a number of seconds, convert that into hours. Now, we will actually do something similar about that on Thursday. So we'll start talking about doing conversions. So Thursday's exercise will help with this fourth problem. So if that looks awful, well, remember, you still, I'm introducing it to you a couple days later. There's still plenty of learning to go on. That being said, if you are having trouble with this, and especially if you know that other people are having trouble with this too, bring it to my knowledge so that I can go over your lab during class, possibly give you answers, or even or the pathway to an answer, depending on the problem. This is something that I am willing and happy to do. The homework is not meant to be a struggle. Okay, it is not meant to be that like it's meant to be, you know, something to help you learn. And if you get stuck on some point, it's not going to help you learn. Again, this is a very new subject for everybody who's taking their first programming course. All right. So with that said, what I'm going to do is I'm going to publish the pre-quiz. Okay. You can find it. So first, give me 1 second. I can't apparently publish it by doing that. So I'm going to hit publish. All right. So you can find it either by going to modules, and going to module 2 and hitting this CS1 pre-knowledge quiz, Python, spring 2023. Or you can go to quizzes and it will be under there now. Quizzes being on this side. Either way, just take a second to go and access it while I go over the over this. This is completely voluntary. You do not have to do this if you don't want to. That being said, you get 5 points for taking it, so, and 5 extra credit points, I should say. It does not matter how many it does not matter how many questions you get right or wrong. You will get 5 questions. You will get 5 points for it. Make sense? It is again trying to figure out, help me see mastery from the beginning of the semester to the end of semester. You can refer to any notes you have, but do not run or execute the code. These codes are these questions are trivial to answer if you execute them. So again, because this doesn't count, because this doesn't matter, please do not run or execute the code. All you're going to do is fudge my data collection up. And I'm giving you 5 points anyway. So we're going to take about 10 or so minutes to do this. If people need more time, I will ask for it. But has everybody found this one? I'm going to go ahead and drop for the people who are on Zoom. I will go ahead and just simply drop a link for you if you're on Zoom. Okay. And then I suppose I could open up Discord for the people who are on Discord and just drop it there. And Discord is an easy way for me to distribute, by the way, snippets as well. But go ahead. So has everybody found it, or does anybody need help finding it? Again, go to modules and then go to module 2. Yes. Sorry? Examples?
The questions are they're not right.
Give me a second. Are they really? Oh, geez. Okay. Give me a second. All right. Okay, give me 1 second. That's easy enough for me that's going to take me about 3 minutes to fix, unfortunately. All right. Let's go ahead and all right. Thanks for bringing that up. All right. Give me 1 second. Okay. Cancel. We have multiple. So notice that it says Python in the title. That's because I have multiple question banks. Okay. So let me go ahead and delete this because that's worthless now. Okay. Let me go ahead and new quiz. Classic quiz. Submit. Sorry about that. Okay. And blah, blah, blah. Okay. Questions. And then let's go ahead and stop share, pause share, and give me 1 sec. New question group. Link to a question bank. Boo, hiss. Okay, course question banks. All right. Why in the world did it give me the Python question bank? Why in the world did it give me the Python? Okay, add question bank. That is so weird. Why did it import the Python questions and not the link to a question bank? Okay. Create group. save, preview. All right, so obviously I'll just simply redo this on Thursday. Okay, that's just simply the simplest answer for that. So if you don't mind, just please just close your windows for that quiz, because honestly that I was like, aha, it worked. And that's the issue when you teach two classes at once. Okay. So all right. Or I can just work on it while you work on the other one. Unless one more second. New quizzes. Let me see. Did it import through there? 0. Save. Build. Okay, add new item banks, this course, all banks. Nope. Okay, that's fine. I will just simply do that. Please ignore everything you saw. So, okay. Regardless, we will just go ahead and fix that on Thursday. I'm sorry about that. Like I said, it's been a bit of a weekend for me. So, all right, with that, let's go ahead and check out our chapter 2 readings. Sorry, not over here. Let's go ahead and go to our textbook. So open up Runestone Academy. Okay, go to Runestone Academy, then go to our course, Spring 2023 Rosen. Okay, once you're there, scroll all the way down again to the project list and go to project 2, Driving the Turtle. So we're going to learn about turtles today, not the very cute reptiles, but the turtle programming paradigm. I believe I have to turn screen sharing back on for this class. Okay, screen 1. Okay. And I'll keep this up over here for a second. Okay. Okay. So Driving the Turtle. So this again is, and if you can't find it, by the way, this one I know is right because I just fixed it before class. Go to module 2 if you can't find it, and click on this first link for this, which is Tuesday will be a Q&A review followed and a short exercise right over here, and it will bring you to this, the page that I just opened up. Otherwise, go to Runestone Academy, go to our course, and scroll all the way down to get to here. Okay, preview the end goal. Okay, Driving the Turtle. Okay. So turtle programs are an old paradigm built into the language, an old language called Logo. And the idea here was getting a very easy to use paradigm to teach children how to program. Wasn't near, and honestly, I think it's a great way to teach adults. Now the current method to teach children how to program as well as adults, or one of the ways is by using the Scratch programming language, which is a whole lot of fun. And that involves programming by grabbing blocks and making variables to do them around. So, and it's all about manipulating these graphical objects. You can make games and stuff in this, and it's actually a programming language. It's just visual, so like have events here, and you can create variables and do stuff with it. It's great. But for teaching you how to use Python and teaching the basic paradigms of Python, these are pretty awesome. So what we can do here is import turtle. So we have this program over here, and if we hit it and run, it does something graphical. And that's why I like it. It's a very easy to understand graphical paradigm. Now, we can also take any of this code, this turtle code, copy it outside of this, paste it over here, and save it. But if you're following my directions, do not save it yet, because otherwise you'll be in for a lot of pain. And I'll call it my program. What I did not call it was turtle. I have an entire video about that for chapter 4. Do not call any program using turtle, because otherwise Python will get very confused. I'll explain that later in a later video. But if you have something that says like it's a recursive import or infinite import issue, that's probably because you named something turtle. Okay, so, but I can go ahead and run it over here and you'll see that it does the same thing. Now, if you are using a different editor, such as VS Code or Spider or something, this window might close after it's done executing. Python just happens to keep it open to make it to be useful. But this web code can be, executed on here. It's all built into your normal standard Python. So you don't have to be connected to the web to do this. So let's go ahead and go through this code and see what it has done. And I will actually reference over here so that we can see what's going on over here. I know it's a bit hard to see because there's a thin line over here. So actually, I'll just grab the output from over here so we can see it a bit better. And then I will read from this side. It's just that makes sense to me. Okay, because it's the same code. So the first thing we need to do for a turtle program to work is we use the command import turtle. This says load up the turtle library so that I can understand all the turtle related commands. Okay, then we have a space because we typically separate our imports from what we actually do. You might have a bunch of imports at the top that do stuff, and then, you have a space to show when they're done because imports are actually rather boring. All right, so the first line is probably the one that will be the most magic for the longest time, which is my turtle is equal to turtle.turtle. It's a lot of saying turtle, and the more you say it, the weirder it sounds. So, but the same principle that I was talking about for the equal sign holds. We take the variable on the right and store it in the, we take the value on the right and we store it in the variable on the left. Make sense? Variable on the right, store it in, variable on the left takes the value on the right and stores it inside of itself. So what this does is that this creates what's called a turtle object. Objects are the big focus of the next programming course, which is 1068, but that doesn't stop us from using them. 1068 goes over not just how to use them in more detail, but how to build your own and how to think about programming in terms of objects, which is a very, very, very useful paradigm for doing a lot of programming. So turtle.turtle creates a turtle. This equal sign, again, stores that in there. Creates a turtle, stores it in the myturtle variable. And now, since myturtle is the variable name, we can just do stuff with on the turtle. So the first one says myturtle.color is green. And as the comment says, it changes the color to green. If I were to change it to over here to be red, right, and run it, we'd see it change to red. It recognizes some colors and not other colors. So if I run pink, it understands pink. If I make pink all shouty case, it understands shouty case too, apparently. So, and as you can see, it's again, same result there. myturtle. And so now we have some commands. So let me change this to an easier to see color. Red. Okay, save and run. Red. And again, you don't have to be working in idle at the same time. I just simply have it so that we can look at the code and the output at the same time. A bit easier. So red changes the color of the turtle to red. Okay, myturtle.forward tells the turtle to go forward 50 pixels or 50 picture elements, right? 50 of those little square blocks. Now, forward, in this case, the turtle starts the program right here. Let me go ahead and change the let me go ahead and change this and the color. So the turtle happens to start the program about right here, you know, in the center, right? The center, it starts, in fact, it starts in the coordinate, in the location 0, 0 on the coordinate plane. It starts at the origin, makes sense. No need to overcomplicate things, right? And in fact, this does work like a coordinate plane when we start talking about specific values. You know, this is, positive X, positive Y, whereas this quadrant over here, whereas this quadrant over here would be the negative X, negative Y quadrant. It works the exact same way as you've seen in all your algebra classes. So nothing too unfamiliar there. The turtle starts in the center and he faces this way. He starts by facing to the right by default. So that is why when he went forward, he went this way. He started facing in the positive X direction, started facing towards the right. Okay, and he moved forward 50 picture elements and he ended here. Then what did he do? We got to the next command, turtle.up, lift up the tail. Now the way this entire paradigm works is you see this arrow over here, that's our turtle. Let me zoom in for you if you don't see him. Right, that's our turtle over here, that little arrow. And you imagine a little turtle and we've attached the pen to his tail. And as he's walking, he's dragging along this pen on this giant piece of paper. Okay, and we've got a bird's eye view of him. So when we give him the command up, he lifts his tail and stops drawing. And then we tell him to move forward another 50. That's why we've got a blank space over there. So 50 pixels of moving forward, 50 pixels of not moving, of moving forward without that. So if we comment these lines out over here and run this on this side of things, we'll see that he moves forward just a little bit, and then he moves forward a little bit without drawing anything. So then we get to the next three commands. Turtle.right. So right turns the so we can turn the turtle left and right. Turning right over here, made the turtle turn 90 degrees to the right. Make sense? He turned 90 degrees to the right. So he was facing, why am I making hand gestures? He was facing this direction. Turning 90 degrees to the right will make him face this direction now. Then we've got turtle.down. Up lifts the tail, down puts the tail back down. And then my turtle.backwards does the exact same thing as forwards, but the other direction. Since he's facing down, he moves up with backwards. I rarely use the backwards command. If I want to go in a direction, I generally turn left and right and move in that direction. Turtles are actually quite useful because you can do a whole lot of things with them, especially when we learn about for loops. In fact, here's an example of the kind of drawings you can do with turtles. Docs, Python, turtles. Let me grab this. Hopefully it still works. So the syntax is a bit different, but I can run it and we can see the turtle. The turtle is really good at creating a lot of spirograph type, art. It's actually rather tiny here. I wish I could zoom in. Let's see. Let's see. I can actually modify this. Turtle.speed, I believe, 0 to make it as instantaneous as possible. And then I will just simply change what he's moving from 400 to 600. That should work. Turtle is not defined. Did you mean turtle? From turtle import star. Fine. Okay, I have to modify the program myself. T is equal to turtle.turtle. Don't have to copy this down. It's fine. Then t.speed is equal to 0. T.forward, t.left, t.pause, t. T dot, T dot. Turtle dot turtle. All right. I'll have to call it turtle dot turtle because. Aha. Okay, I figured out what I did wrong. There we go. Reading the code explains the code. I don't need a turtle for there because it's built in, right? There we go. Make it bigger and there we go. It's a lot. So I sped up so what I did is that I sped up the time and made it and changed the 600 to 300. Sorry, the 200 to 600 to make it bigger. But this kind of pattern is what the turtle program is extremely good at doing. Spirographs and that kind of stuff. Advanced geometrical patterns, interesting shapes. You can make some basic games in Turtle, but I don't recommend it. There are a lot. It's not that you can't do it. It's just that Pygame makes that easier if you want to do games in Python. But turtles I find are a valuable teaching tool. You can also tell them to, so what else can we do with turtles? Well, we can tell them to, well, now I'll work in here. I can tell them to go to specific locations. So here, my turtle is a turtle. My turtle color is equal to red. My turtle dot go to square 100 comma 100, and the turtle will go in that direction. So the square went to 100. So it went to 100, and then it executed the rest of the program. Let me put him to 50-50 instead, because that kind of went off the screen. So he went to 50. So you start at, so I added another command. And there's an entire chapter where we go over this. It's about 5. It's chapter 5 or so, and we go into a lot of ideas of how to do turtles. And yeah, the commands we have are forward, left, right, up, and down, and color. But we do have a lot of other commands in terms of turtles, and you can look them up in the Python documentation. You can just simply search Python turtle documentation to get to this. And you see that there's up and down, pen up, pen down, PD, PU. Those are all commands for the same things. Width to change the size of the pen, change the color, make it so that you can fill what you're fill the shapes you're drawing. You can change the shape of the turtle, actually. So in fact, let's go ahead and see that. Let's see. So let's go ahead and change over here. So we're going to say, very first thing we'll do is my underscore turtle dot shape is equal to turtle. And it actually changes the shape of the turtle that we're working with to that of an actual turtle, which is, I find that cute. I find that nice. I find it a very nice and unnecessary touch in the programming language. So you can make, and again, you can mix up these things, these commands all together. We'll be seeing how these work in the end of the semester. We'll be seeing how this works over the next couple of weeks and how it ties together with when we do for loops to do repetition, how you can do if statements to alternate things with turtles. It ends up being a lot of fun. And in fact, we will revisit this in class with exercise 4 when we talk about how to use turtles to draw different basic shapes. I think one of these talks about how to do graphs with turtles, but I skipped that one because it's a lot more fun to use an actual, language that meant for graphing, like Kiva. Sorry, Altair, to show how to do Kiva. So what I want you to do for the next 10 or so minutes is see what you can is the next part of the exercise, which is to experiment with the turtle. I'll go ahead and I'm going to also show you how this works. I'm going to hit this button over here called share code. You're about to share this code with all your students. Are you sure you want to continue? Yes, I wouldn't hit the button otherwise. Shared code with 177 students. So now if you reload your page, inside this bar will be, and you'll have to reload the page to see it, but inside of this over here will be, a notification or a snippet of code where it's the code I wrote here. So you don't have, so if you're worried about furiously copying things down and making mistakes somewhere, it's not something you have to worry about. It's actually a really great feature. So what I want you to do over here, while I can see if I can't recover the quiz that I was trying to give out for the next 10 minutes, is working over here and try to work on making your own shape. Get to know the turtle, try to, make your own shape, get practice with creating a variable and then using the commands of an object. So with that, I'll pause sharing and get to it. I will be back. Please don't leave when you're done, because again, I'm going to see if I can't recover the quiz that I was trying to get done really quickly. Okay. Okay. Quizzes. Pre-knowledge. CS1, pre-knowledge quizzes. Review. Okay, great. Getting this quiz. Questions. Yes, on Python. Bookmark this bank. Okay. Quizzes. And yes, you can work with other people on this. So you don't have to be quiet. Mm-hmm. Yeah, it's just emergency.
Oh, this one? Like, it's so it's just, like, if you just been using the title, yeah, you can just download this, like, and there's no, it's just like a little more. Yeah, and there's like a separate output mode right there, and it's just really. Yeah, so it's just called Python, but there's a bunch of different.
And I also don't have any preference as to what students use. My philosophy on editors is you use what works for you. So if you want to use PyCharm, which is about as heavyweight as it gets for Python programming, then you can go ahead and use that. I use idle specifically because it is built into downloading Python. So when you're learning programming the first time, I don't have the additional instruction of you also have to download another program, right? I only have to tell you to download Python, and boom, you have a way of downloading of working in Python. Mm-hmm. Mm-hmm. There we go. Okay, pick 5 questions, 0 points per question, save, edit, details. How many points? 0 points. Save. Oh, I said 0 points. Come on. Get it right. No, wait, new question group. Select bank, save. 5 question. Oh, okay. Okay. 5 questions. 0 points per question. Python. Link to a question bank. CS1, select bank, create group, save. assignments. Oh, great. Now I've got, oh no, now there's two of them. Edit. Edit. Delete. Okay. Okay. Do. Save and publish. You save. Preview. Aha. All right. Saved. I managed to recover the quiz. What it was is that it was linked to the wrong question bank. So we will deal with that when we are done. So I will publish it and move it to the appropriate place in modules. And okay, and we will add this. Add, boom. There we go. All right. Resume share. You know, that's funny. I never crossed the recording, so they're going to have to deal with there's going to be all this noise in the recording. Okay. So is anybody having any difficulty with trying to create a shape or anything like that? Or does anybody have any questions about turtles that I can assist with? I mean, while we're still working on this, it's very easy to kind of use turtles to kind of create basic shapes just by copying and pasting like crazy. So for instance, if I import a turtle, oops, yeah, you can't see anything I'm doing. That was kind of intentional, but that part wasn't. Okay, import turtle. So I'm going to create a new turtle. I'm going to call him Bob, mainly because Bob is 3 letters. Also, Alice and Bob are classic metasyntactic variables in computer security. Alice and Bob being 2 people trying to communicate with each other, and Mallory being the malicious actor, malicious Mallory. So always use, again, it's all about having more than just those just one letter for variable. So Bob is equal to turtle.turtle. Bob is equal to, sorry, Bob dot forward 100, Bob dot right 90. And if we just simply copy paste this a few times, 1, 2, 3 times to get a total of 4 of these repetitions, we get ourselves a nice square. In fact, you can do this with any number with a polygon of any number of sides by using the appropriate angle and the appropriate side. So for instance, if I want to make a triangle, I would instead I mean, you can make however big you want. I do 100, and then for the angle, I wouldn't do 60. You'd think it'd be 60 for triangles because, you know, that everybody knows that, or everybody has been taught, I should say, that the inner angles of a triangle add up to 180. But that's different if you're trying to draw it by making turns. When we're trying to draw a polygon, we need to make, you know, a shape that basically, you know, if we're trying to draw a shape that has sides and not any of those weird curvy nonsense, then we need to add up to 100. We need to add up to 360. And if I wanted to face up, I would just simply change this from right to left. And this also has the convenient feature that Bob's going to end up where he started. So there we go. It's not particularly a, you know, it's not, you know, the most compelling shape, but there's lots of drawings you know, as any elementary school kid has been taught, there's lots of fun things you can make just by using basic polygons. That being said, I mean, like what we're going to be doing in lab 3, if you want to take a look at that at some point, it talks, we're going to do things like make the Triforce, make the Olympic rings, create a clock made out of, you know, draw a clock, you know, do some basic drawing with using these turtles. There is one thing that will be mildly annoying for some people, which is writing your initials, which depending on your particular initials, that can be tricky. So J is one of the trickier letters to do there. So, whereas, you know, E's or F's are fairly straightforward, but, you know, somewhat tedious to do. So that could require you getting creative, but that's lab 3, and we haven't even gotten to lab 2 yet. So now that we are here, I've got it fixed. And now that you have, so let's finish up with this. So if you're done, so with Runestone, right? I completely and totally did it in the wrong place, but hey, I'll drop it here. So with Runestone, right? Just whatever code you did, make sure you run it so you get credit, and then answer these questions with regards to the project about how this made you feel. I do look at these to try to get data as to like, how are things going? Are they going too fast, too slow? Is this interesting or not? You know? So once we're done with that, now we can go to the you know, the mastery quiz that I have set up. So we can go to modules. Okay. You can go to modules 2 where the quiz used to be located. And then you can see, and then you can do this quiz, and it should be in Python this time. It should be. I hope to God, because otherwise I've messed up twice. That's fun. Except this time I won't have an excuse. All right, so go ahead and access that quiz. Again, you can go to find it under modules, under module 2, variables, or go to quizzes and find it as the only like active published quiz. Did everybody see it? All right. So please go ahead and take that quiz. Once you have taken that quiz, you are free to go. You guys took it? Great. And if you want to come and ask any questions after you're done taking the quiz, you're also able to come over here and ask me questions. I look forward. So on Thursday, we will have our first actual maybe mentally challenging exercise we're going to do from the textbook. I do try to go slow for the first 3 days. Hey.
How do you demo, like, I've already done lab 1 already, but how do I demo it?
So once class is technically over, so let me stop screen sharing.
Yeah.
Over here, and let me go ahead and start recording.